Welcome to Laws of Indices Level 2. Pause the video now, try the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying y to the power of 3 raised to the power of 2 multiplied by 4y to the power of 8. Starting with y to the power of 3 raised to the power of 2, we have a power raised to another power. So using this law, we can see that we need to multiply those powers together. So multiplying together 3 times 2, we have y to the power of 6 multiplied by 4y to the power of 8. Now here we're multiplying indices together, so we're going to use this law, which tells us that when we multiply indices together, we have to add the powers. So starting with 1 times 4, we have 4, and y to the power of 6 multiplied by y to the power of 8 gives us y to the power of 6 plus 8. Since 6 plus 8 is 14, our final answer for problem 1 is 4y to the power of 14. In problem 2, we're evaluating 7 to the power of minus 2, which means we need to find its value. Since we have a negative power here, we're going to use this law, which allows us to rewrite 7 to the power of minus 2 as 1 over 7 to the power of 2. And since 7 to the power of 2 is 49, we have our final answer, which is 1 over 49. In problem 3, we're simplifying 2q to the power of 5 t to the power of minus 9, all raised to the power of 7. Since we're raising powers to powers here, we're going to use this law, which tells us that when we raise a power to another power, we multiply the two powers together. Now before we start, it's important to rewrite this 2 as 2 to the power of 1. And now we've done that, we can start multiplying our powers together. So starting with 1 times 7, which is 7, we have 2 to the power of 7. Next, we multiply together 5 and 7, so we have q to the power of 35. And finally, we multiply together minus 9 and 7, which gives us t to the power of minus 63. Now simplifying further, 2 to the power of 7, which is 2 times 2 times 2 times 2 times 2 times 2 times 2, we have 128, q to the power of 35, t to the power of minus 63. And that's our final answer for problem 3. In problem 4, we're evaluating 4 over 5 raised to the power of 3. And to evaluate this means to find its value. To start with, we're going to rewrite 4 over 5 as 4 to the power of 1 over 5 to the power of 1, all raised to the power of 3. And it's important to do this because we can now see that this problem is about raising powers to powers, which means we're going to use this law, which tells us that when we raise one power to another, we multiply the two together. So starting with the numerator, we can multiply together 1 and 3, which gives us 3, and our numerator becomes 4 to the power of 3. Similarly, in our denominator, 1 times 3 is 3, so we have 5 to the power of 3. Now 4 to the power of 3 is 4 times 4 times 4, which is 64. 5 to the power of 3 is 5 times 5 times 5, which is 125. And that's the final answer to problem 4. In problem 5, we're told that h to the power of n over h to the power of 5 multiplied by h to the power of 12 is equal to h to the power of minus 5, and we need to find the value of n. Starting with the left-hand side and looking at the fraction, we can see that we're dividing two indices together. So to simplify this, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So this means that h to the power of n over h to the power of 5 becomes h to the power of n minus 5. This is still being multiplied by h to the power of 12 and is equal to h to the power of minus 5. Now, still on the left-hand side of the equation, we can see that we're multiplying indices together. And when we multiply indices, we use this law, which tells us that we have to add the powers. So the left-hand side of the equation becomes h to the power of n minus 5 plus 12, using our law. And that's equal to h to the power of minus 5. Simplifying the left-hand side, we have h to the power of n minus 5 plus 12 is positive 7, and that's equal to h to the power of minus 5. Now, since the left and the right of this equation are equal, and they both have the same base, which is h, we can now say that their powers must also be equal to each other. So n plus 7 must equal minus 5. We can solve this equation by subtracting 7 from both sides, and we get to our final answer, which is n is equal to minus 5 minus 7, which is minus 12.